Section 4.4 in your student journal, scatter plots and lines of fit. What page is this? 106. How can you use a scatter plot and a line of fit to make conclusions about data? How can you use those things if you don't know what they are? So, a scatter plot looks something like this. It's just a set of data on a graph, essentially. It's scattered because, well, it's called a scatter plot because you have a bunch of points just scattered throughout the graph. A line of fit is generically just whatever line where that fits those points. So for instance, if I just had to ballpark this one, if you're saying, oh yeah, most of these points lie along a line, what would that line look like? Well, something like that, right? Or if you had to guess, really, I mean, if you did anything like that, all this makes sense. Just what line covers the general trend of these points. Okay, here you can see that it's definitely going up. So I don't know that there's like a, oops, I didn't mean to do that. Something that might look like that. Sure, that fits. You got some above, some below, one on, as close as you can get. Yeah, something like that. None of it has to be perfect. You just have to have a good sense of, looking at it and seeing, oh yeah, what line fits. So a scatter plot, like I just said, just shows any number of data on a graph. Really shows the relationship between two data sets. Correlation, well, it has the word relation, so you should think about like a relationship. A correlation is like, oh, well, for instance, I'm not going to give you the dictionary definition. If you want, you could look it up, or you could find it in your textbook. But the correlation is just like the relationship between the data sets. So in this instance, the correlation, if it's going up, would be a positive correlation. If it's going down, whether it's going down by a little, going down by a lot, if there's a clear trend, there's a correlation. And so this is considered positive correlation when it's going up and negative correlation when it's going down. If it's scattered, if it's truly scattered in that you see no trend, then you would just say that there is no correlation, little to no correlation. Line of fit is that line that I was showing you guys earlier. Moving on to page, using a line of fit to model data. Make a scatter plot, decide whether the data can be modeled by a line, because sometimes it can't be modeled by a line. Draw a line that appears to fit the data closely. There should be approximately as many points above the line as below it. Again, this is just a rough guidance, really. It's not like anyone's going to count and be like, oh, there are 4 points above your line and 4 points below. It's got to be exactly like that. Write an equation using 2 points on the line. The points do not have to represent actual data pairs, but they must lie in the line of fit. So when you have 2 points, you guys now know you have the skills to make a line, finding the slope using y2 minus y1 over x2 minus x1, and then using the point slope form. What does that look like? The scatter plot shows, so really this is just asking you, can you read this graph? So what is the weight of the baby when the baby is 4 months old? We'll go to 4 months. What is the weight? 14 pounds. So you'd say at 4 months, the baby weighs 14 pounds. What is the age of the baby when the baby weighs 17.2 pounds? 17.2. 17 is between here and there. That looks about it. 8 months. You say the baby weighs 17.2 pounds at 8 months. Okay. Again, this is just you guys being able to read. Just look at it carefully. What tends to happen to the weight of the baby as the age increases? Well, that's kind of it's a positive correlation. If it's positive, what direction is it going in? It's going up. If something is going up, is your weight going up? Are you getting heavier or getting lighter? Right. So you could say the tendency is for a baby's weight to increase with age, which should make lots of intuitive sense. When something grows, it gets heavier. I'm just going to go through these verbally real quick. Well, I always say that, but I'll show you anyways. Positive, negative, none. Number 3 is none. There's nothing clear there. You can't say it's going up or down. And number 5 is positive. Write an equation that models the depth of the water as a function of time. Let's see here. So x, no, it's just, we're going to take this horizontally. So we'll say time 0, 2, 4, 6, 8, 11, or sorry, I'm not thinking about that. 10, 12. Sorry, I'm using the x for those values. Let's see here. We are going all the way up from 6 to 24. So let's, how do I want to do this? Let's say, oh, I guess we just go up by 6. 6, 12, 18. Oh, it's kind of a lot. Let's go up by 4s. 4, 8, 12, 16, 20, 24. Okay. So I know it's not perfect, but I mean, you know, just bear with me. 0, 6. So that's between 4 and 8. 0, 6. 2, 8. 2, 8. 4, 11. 6, 14. 12, 16, 14 is right in the middle. 6, 14, 8, 17, which is just above 16. Where are we? Yeah, that was 8, 17, 10, 20. 10, 20, and 12, 24. So write an equation that models the depth of the water. This does not have to be perfect, but you know, something that looks like that. Looks like it fits the points pretty well. You know, if you're like this, I don't think that's really much to penalize you for. Anything within this range is pretty acceptable. I will just say like that. And we can just make our 2 marks, or pick our 2 points. Let's say 10, 20. Again, the note said that it does not have to be numbers from the actual data set, but also like this looks like it fits pretty well anyway, so I just will. We have 10, 20, and 0, 6. So you can pick your x1 and y1. I'll do it like this: x1, y1, x2, y2. So we're gonna find, we need to do, we don't need to, but I mean, it's the most obvious one, point slope. So we need a point and a slope. So let's just use 0, 6, and let's find our slope. y2 minus y1 over x2 minus x1. So we have 20 minus 6 is 14 over 10. So our m is 14 over 10, or 1.4. So I could say y minus, so point slope form again, y minus y1 equals slope times x minus x1. So I have y minus, what's my y1? 6 equals 1.4. If you want to write 14 over 10, that's fine by me, or 7 over 5 even. X minus 0 is just x. Well, I'll write the 0 and then I'll show you guys. Y minus 6 equals 1.4x. Some of you, if you come up with something different, if you really anything between I guess 1.2 and 1.6 or even 1.7 might be accurate. I'm not gonna do it myself, but again, this is just a rough. You know, drawing of a line. If you want to do, if yours is not exactly the same, that's okay. This is just a rough. It's just a rough sketch. Interpret the slope and y-intercept. So the y-intercept is when you started, there was already 6 centimeters of water, so you might say, oh, there, before filling the bathtub, bathtub, not bathrobe, there was already 6 centimeters of water. And then the slope is every minute. So the slope is 1.4. So every minute, the water level increased by 1.4 cm. There you go. Okay. Oh, and that's it for section 4.4. So we finished with lines of fit. Hopefully you understood it. Again, it's just very rough. You just have to understand when things are going up, positive, or down, negative, or if they have no relation. Besides that, a line of fit's kind of sketchy. It doesn't have to be too precise. And I think it's mostly a conceptual section of the book that you should understand. But if you have any questions, as usual, ask your teacher or let me know.